And turn the recording off. Oh. So 6.2, applications of the normal distribution. Remember, normal means I'm looking at a bell-shaped curve, right? So and then we have some examples of what this looks like. So we're going to remember our formula here, our z-score formula, very familiar to you. X minus mu over sigma, where X is an individual score minus the mean divided by the standard deviation, okay? And we know that to get area under the curve, we're looking at the area normally on the left. So we go through that instructions. Those are there for you. And the distinction in this that starts in this section and continues is we can be talking about one individual person, or we can talk about a group of people. Right now, we're going to be talking about one individual person. So here it says most tests that measure one's intelligence quotient are designed to have a mean of 100 and a standard deviation of 15. So we're given the mean, we're given the standard deviation, and we want to sketch the distribution, which just means show us what the curve is going to look like and what is the probability that an individual is a potential genius. A potential genius, I should keep reading. In 1916, psychologist Louis M. Thurman set a guideline of 140 scaled to 136 in today's tests for a potential genius. Let X be the measure of one IQ, sketch the distribution, and then what is the probability that an individual is a potential genius? So here, this should look familiar to you. Here's your normal curve with 100 in the middle, because that's the mean. Standard deviation is 15. So there's 100 plus 15, 115, 115 plus 15, 130, 130 plus 15, 145, and then subtract 15, 100 minus 15, 85, and so forth. That's the distribution. And it's asking you for the probability that somebody is a potential genius. That means their IQ, according to this problem, is at least 136. So there's your X. 136 minus 100 gets your z-score. Round it to two places. Then you're looking for the area larger. So you're going to go to your calculator and find the normal CDF of that, okay? And most of the problems are going to work like this. We can also go backwards and given an area we can find, and we'll talk some more about that when we get there. But let's go ahead and look at, oh, wait a second. I've not got, all right, I thought I had it open, but I guess I don't. So let me go ahead and bring up the homework. I think the first homework, oh, I had it here. I just didn't open it. That's not very helpful, is it? All right, let's see what I got here. 6.2, here it is. So it says, the average early bird special admission price, let me put it on the screen. The average early bird special admission price for a movie is $5.81. If the distribution of movie admission charges is approximately normal, with a standard deviation of 81 cents, what is the probability that randomly selected admission charge is less than $3.50? Okay. Well, we start by drawing a normal curve. And since she didn't say that you had to actually draw, you don't have to show 3 deviations, but you do have to draw this. So here, you're gonna say, you're gonna go ahead and you're gonna draw this out. So we're gonna have a line here. We're gonna have the distribution. Something like this. Your mean here. There it is. Your mean is $5.81. Okay. That's what it told you. Okay. Your mean is $5.81. And it says that, go back. If the distribution is approximately normal with a standard deviation of 81 cents, what is the probability that the charge is less than $3.50? So we know here that this is mu. This is mu is equal to $5.81. 350 is going to be somewhere to the left of this. Okay. And since it's 2 standard deviations, maybe it's about here somewhere. This is $3.50. Okay, this is my $3.50 mark. Now, I want to know what the probability is that it's less than that. So this is where your calculator comes in, but we need your z-score first, okay? So what we're going to do is after we kind of can visualize this, once we can visualize, then we draw. So we draw this out. We're looking for this probability in the tail here. And we want to find the z-score. So this is where our formula comes in that we were reviewing. So we have z is equal to x minus mu over sigma. Okay, so we have that. What is my x?
The mean.
No. Mu is the mean.
Oh,
So in this case, mu is always the number in the middle. Mu is, in this case, it's $5.81. Okay. X is whatever I'm trying to find the probability for. Okay. So X here would be what?
0.81.
Let's go back to the problem. I need to show you something. Okay. We have, let me give you this first though. When I calculate the z-score, all right, let me remind you of this. When I calculate the z-score, X, I don't know why that's green, but let me change it to black. X is my my score or my value of the variable that I'm looking for. Mu is my population mean. In the middle of the distribution. And sigma, which I'm going to write as O on here because I don't have the symbol. Sigma is my population standard deviation. Okay. Those are my values. So I need X, I need mu, and I need sigma. Mu is $5.81. X here is going to be $3.50. I'll show you why in a minute. X is $3.50. And my sigma is 81. That's my standard deviation. So my sigma is 81. Okay. 0.81, sorry. 81 cents. So this is what now, let me go back because I promised I would go back and share this.
Oh.
The average early bird special admissions price is, so average is another name for mean. We have two means. We have the sample mean, we have the population mean, but the average is 581. Okay, that's what it said. The average is 581. Then it said that, there it is. Let me erase a few of these. My average is 581. If the distribution is approximately normal with a standard deviation of 81 cents, that's my sigma. What is the probability that a randomly selected charge, so whatever you're randomly selecting, that's your variable, that's your X, that's less than 350, okay? So that's how this works. All right, so let's do this and let's see what we get. All right, so we're gonna go ahead now and I'm going to get my mouse back if I can find it. There it is. Okay, I'm gonna clear my drawings and I'm gonna grab my mouse cursor. All right, I'm gonna get my calculator. So I'm gonna share the screen here. And we're going to put it in. Let me fix this. I'm gonna get this back and clear everything out. Clear the history. Yes. Okay. So we have X, which is 350, minus the mean, which is 581, divided by 81 cents. Like so. Okay. That gives me negative 2.85. Okay. Now I'm looking for the area to the left of 2.85, negative 2.85. So I'm looking for something that is like this. Here's my distribution to remind you. And I have, oops. No, that's not what I, okay. Here it is. So I've got a negative here. So this is this answer. And I'm looking for this tail. How am I going to get this tail area? How did we do that in section 6.1? Do you remember? Negative 2.85. I need the area in the left tail. How do I get that?
Distribute.
Well, no, I have to use inverse. I mean, I have to use normal CDF. So I go second distribution. This is where I go second distribution. Normal CDF number 2. And I'm going to go, where's my, if I'm looking for this area here, if I'm looking for this area right here, where's my lower going to be? It's not going to be that. It's not going to be, okay, I don't know. This came from a previous problem, so you can ignore that. What is my lower in this problem?
Negative 2.85.
Well, that would be true if I was going from, that would be true if I wanted the area from 2.85 up. But what I want is this tail. So what I want is this part, okay? So what I have out here is actually negative infinity, right? So the way I enter infinity on my calculator is I say, this is, we usually enter it as negative with the negative sign, right? Then E, which now when you use the E, you want to use the E that's on top of the comma. So we're going to go second E 99 negative infinity, and we're going to finish the region at negative 2.85. And we're going to enter that. Mu and sigma are 0 and 1, so we can leave that. And we have 0.0021 or 22 if she's 22 if you round to 4. I'll have to look at the answer and see. 0.0021. So now let me go to the homework and see what she asked for in the answer. So here's your, oops, no, there it is. Yeah, she rounded these to 4 places. So 0.0022 is the answer to number 1 here. Okay. 0022 is your answer there. Okay. So we're looking at this. This answer is when we put it in, it's 0.0022. And that's what and you can turn that into a percent if she asks for probability. So this is going to be or equals 0.22%. Okay, does that kind of help a little bit? I know it's going to take some time to get used to this, but remember, these symbols are the same as what we've seen in the previous section. So it's similar, you just have to pick out the numbers from there. Okay. Sometimes we need one z-score, sometimes we need two. We'll see that when we go to the next problem. Any questions about this one?
No.
No? Okay. Let's continue. Let's go to number 2. Number 2 says, the average daily jail population in the United States is 706,242. If the distribution is normal and the standard deviation is 52,145, find the probability that on a randomly selected day, the jail population is. So we have two situations here. One is greater than 750,000. And part B says between 600,000 and 700,000. Okay. So let's pick out our parts. Remember, we need the mean. We need the value of the variable. And we need the standard deviation. So what do you think the mean is here?
The mean is 706,242.
That's right. That's mu. Okay. Now, if the distribution is normal and the standard deviation, so what is that 52,145?
The standard deviation.
Right, and that goes in the denominator, right? We're dividing by it, which leaves our x to be what for part A?
750,000.
Yeah, exactly. So our distribution looks like this. This is, let me share the screen. Let me get a new page here. So we're looking here and it says that, I'm gonna graph it. And we have our curve, right? Something like this. And in the middle, we have 706,242, right? And we're looking at 750,000. So 750,000 is going to be over here somewhere. So I'll draw another line that represents, it doesn't have to be exact, but it has to be on the correct side of the distribution. So 750,000 here is that number, okay? And I'm looking at greater in part A, right? So I'm gonna say that this is greater than this, and remember I need the z-score. So let me put a line under here so I can include, remember the mean of the distribution is 0. So if I'm looking at my z-score, let's calculate that. Calculate the z-score for 750,000. So let's do z is equal to, remember the formula is x minus mu over sigma. So it's just about plugging in the numbers, okay? So Z is going to give us, this is going to be 750,000 minus my mean, which is 706,242. And I'm going to divide that by my standard deviation, which is 52,145. So let's do that. And let's see what we get. We have 750,000. 1, 2, 3. Oops, did I get too many? No. Minus 706,242. We divide that by 52,145. And we get, okay, what are we going to use? If we round to two places, what is our z-score here?
.8391. No,
Okay,
92.
our z rounds to 2. So we're going to use 0.84, right?
What?
This is your z-score. This isn't your area yet. Your z-score rounds to two places. So use 0.84 as your answer there and put that in your next step, okay? This is 0.84, right? Because it's 839. Okay?
Mm-hmm.
All right, now, remember we want greater, right? So how are we gonna get that? What are we gonna do?
Normal CDF.
Normal CDF, very good. So second distribution, normal CDF of what?
Uh, 0.84
Good, 0.84 to what?
to infinity.
To infinity, whoops. My mouse is going crazy, excuse me. Yes, infinity. And so we put that in with our second E right here, like last time, except this time we don't need a negative in front of it. E99. 0 and 1 we leave alone, and we end up with, now this one you round to 4 places, so it's 0.2005.
Because apparently on the answer key it says 0.2007.
7. I wonder if she used, let me see if I entered everything correctly. 705. Let me check the numbers and I'll see. 20, okay, so this is 750,000, that's right. And 750,000, 706,242. Okay, let's see. $52, 140. Okay. Is that what I put in the calculator? Let me see. 52, 1. Okay, let me go up here and check. Yeah.
Oh, maybe it is the the thing on the answer key is wrong.
Maybe, yeah, I think. Yeah, I have 0.2005. Let's do part B and then I'll let her know, okay? But it's 0.2005 or 20.05%. So this was 0.2005. Okay. All righty. Now, okay. Let's go and do part B of this question. Now, part B is kind of similar, but we're going to have to get two z-scores because it's between 600,000 and 700,000. Okay. So we're going to have to get a z-score for 600,000 and a z-score for 700,000. So let's see if we can do that. Okay. This is going to look like this. So I'm going to leave the 0 there. And I'm going to well, maybe not. Maybe I'll redraw it for the sake of the whiteboards. Okay. So distribution. Middle number. Here's our middle. This is 706,242. We're going to find a z-score. We have 600,000, which is somewhere over here. Okay. Let's say this is 600,000.
Wouldn't that be the negative side?
Yeah, because the mean is 706. Yeah, so they're both on the left this time, right? Because, but that's a good observation. So both of your z-scores should be negative, right? So you've got 600,000 here. You've got 700,000 here. So this is 700,000 here. Okay. Now let's do our, I'll put another line down here so we can reference our z's. I'll do a line here. So this is 0 because it's the mean. That's our 0 there. Now, let's go ahead and do it for 700,000. Remember, your x comes first in the formula. So this is going to be z is equal to, here I have, this is going to be x minus mu over sigma, okay, like that. Then in our case, that's going to be z is equal to, for 700,000, which, did you do 700,000 first or 600,000?
600.
600, okay. It doesn't matter. I'll do that just so I follow you. 600,000 minus 706,242. Be careful not to subtract your x's from each other. Subtract it from the mean, from the middle score. 706,242. And our standard deviation is 52,000 145. And our other z-score will be, let me set it up and then I'll put it in. Z is equal to 700,000 minus 706,242 over 52,145. Okay. So let's crank through this and see what happens. So for $600,000, I'm gonna cheat a little bit since I have the number already. 600,000, 600,000 minus 706,000 divided by 52,145. I have a negative 2.04 if I round. Okay.
Wait, what?
I got negative 2.04 for my z-score for 600,000. Right?
I don't know. I got a different one.
You got a different number?
Mm-hmm.
600,000 minus 706,242 over 52,145.
Okay, there we go. Added an extra 0.
That'll do it. Been there, done that plenty of times. All right, I'm gonna do it for 700,000 right now. I'm just gonna
Wait,
save myself.
what's for the -2?
What was that?
What's for -2?
So that's your z-score that corresponds to 600,000. So right now, that's this z-score here. So this z-score here, this 600,000, let me move the box. Okay, this z-score here is negative. If I round it to two places, I get negative 2.04. 04. Okay.
Mm-hmm.
Now
Oh, I get it now.
I'm gonna do the same thing for 700,000. And then we're gonna find the area between it. Okay.
Mm-hmm.
So let's go back to the calculator. And the only thing that changes in this calculation is the first number in there. So this is going to be, oops, let me grab that and put in 700,000 this time. And I get negative 0.1197. So this is going to round to negative 0.12.
Yeah, I got that.
Okay, so we have negative 0.12. So we have anywhere between negative 2.04 and negative 0.12. So now this is negative 0.12 here. Z is a negative, oops, negative 0.12. And so to get my probability, which I'll write that. I haven't shown you how to. So probability of, first you write the X. And so we're writing 600,000, like so, is less than, because we're doing between here, less than X, less than 700,000, just like we did in the previous section. Then we change it to our Z. This is equal to probability of negative 2.04. Oops. Need to make it. I wasn't trying to minimize using. Okay. Negative 2.04 is less than Z, which is less than negative 0.12. So now let's go to the calculator and let's see what we have. So we're going to go to the calculator. We're going to go second distribution, normal CDF, number 2. We're going to go from negative 2.04 to negative 0.12. So negative 0.12. And that is going to be I have 0.4316 is what that is. Let me make sure it went incorrect. Yeah, it did. So I have this answer is 4316. So now let's check that. Sharing the calculator screen. Get the homework back. Okay. So let's see. Yeah, that one worked. 0.4316. Okay, you want to try number 3? Let's try having you set this one up. See if you can get it.
Wait, hold on. For A, what's for A? For number 2?
For number 2, we got greater than 750. So that was, let me go back.
Oh wait, never mind, I found it.
Our final answer was 0.2005. Okay. Okay. So are we good with the first 2?
Yes.
All right. Let's see if you can set up number 3A. Okay. The average number of calories in a 1.5 ounce chocolate bar is 225. Suppose that the distribution of calories is approximately normal with sigma equal to 10. Find the probability that a randomly selected chocolate bar will have between 200 and 220 calories. A.
Between.
Mm-hmm.
So 225 minus 200 divided by 10.
Close. Remember, you start with the X, not the middle. So it would be, if you're doing 200, it's 200 minus 225 over 10. And 200 minus, 220 minus 225 over 10. Because this is this.
Can't see.
I know, it's coming. It's coming.
Okay.
But thank you for letting me know. So here, I don't want a rectangle. I want a. So here's my distribution, right? This distribution is oops. This is not going to look very symmetrical, but all right. So this is your middle. So this is your 225 calories. Here, this is mu. This is mu equals 225 calories, okay? And you're between, as you said, two numbers that are on the left side of your mean, right there. So there's a 200 and a 220. So this is going to be 200 here. And this is going to be 220 here. So we're looking at this piece in the middle, somewhere there. So when you do your Z, I'm going to remind you again, because that's very common. The Z is your X minus your mean over the standard error deviation. So like that. Okay. So here you get, let's come to the calculator and let's do this. This is, let me clear out some of this mess. Okay. So we have 200 minus 225 over 10. Oh, that's nice. That's an exact negative 2.5, right? And the other one is going to be 220 minus 225 over 10. That gives you negative 0.5. Okay. Those are your z-scores. Okay. So here we're going to have this is going to be negative, what's that, 22? This is going to be z. This is, z is a negative 2.5, right? And then this other one is going to be, oops, z is going to be negative 0.5. Okay, those are my z's. Now, I'm going to go to the calculator and get my normal CDF. So here, I've got second distribution, inverse, I'm sorry, normal CDF from negative 2.5 to negative 0.5. 0 and 1, I paste it. And I get 0.3023. 0.3023 is my answer there. So now okay,
Oh, I got the answer.
you got it to work. Good job.
Yep.
Now part B says less than 200 calories. You already have the z-score for 200 because you did it for part A, right? But you're finding a different area here, okay? What do you think you would do with less than 200 calories?
Hmm.
Are you there, Jason?
Yes.
What do you think about less than 200 calories?
Less than 225. It equals negative 0.5.
Okay, that's a z-score of negative 0.5. That's right. Now, which way are we going to go for part B of the question? Because we're not going to be between it, are we?
No.
So part B is we're going to have to find a different area, right?
Mm-hmm.
We're looking for, we have our curve, whoops, sort of. We have our curve right here, right? And this time, 200 is over here, just like before. This is a z-score of negative, is it less than 200 or less than 220? Let me read it again, because I don't remember what I read. It says less than 200, so we're using the negative 2.5, right? So we're going to say that I have my here's my z is equal to negative 2.50. And I'm looking at this area here. All right. I'm looking at that. So when were you able to get the answer for that? Or are you still working on that?
Hold on. Since it's a negative, does that mean there's a negative infinity?
Yes. So when you write this in, you'll write, let's see, let me share the calculator. That's a good question. We only did, yeah, because this is a left infinity. So we're going to go second distribution. We're going to go normal CDF like we do right here. Then we're going to enter, we're going to keep the negative, but we're going to enter infinity. The way we do that, remember, is with the E on top of the comma right there and 99. Be sure you enter the negative sign before it. The upper is actually negative 2.5.
Wait, what?
0 and 1,
2.5? How'd you get a 2.5?
because that's the z-score for. So if you remember, let's go back. This is asking you for less than 200 calories, right? So 200, unless I'm mistaken, let me check. 200 was a negative 2.5 z-score, right? So I'm looking for this area here. So I go from negative infinity to negative 2.5, right? I don't want to go up to 220. I want to go to 200. So I'm going to use the z-score at negative 2.5. Okay?
I'm lost.
Okay. So you were okay up here, right? When we did so we had 2 z-scores in part A, right?
Yes.
The z-score for 200 was a negative 2.5, wasn't it?
Yes.
Let's do it again. Z is equal to, because we're doing less than 200 right now, correct?
Yes.
So let's do this again. We have the x, which is 200, minus the mean, which is 225, over 10. Is it 10? Yeah. I think it's 10. I'm pretty sure it's 10. Is it 10 or is it, let me look.
It's 10.
I'm having a brain freeze myself right now. Yeah, so that works. So now, let me see where I was. Lost my train of thought for a minute. This is 10 down here, right? So when we calculate this, we should get the same z-score that we got when we calculated it the first time, right? And that was 2.5, negative 2.5. Is that, do you remember now?
Mm-hmm.
Okay, so that z-score is this z-score down here. Okay. And I'm going from negative infinity, because that's out here, to that z, which is negative 2.5. Okay. So when I go
Yes.
to the calculator, I get this.
Mm-hmm.
Okay, better?
Yeah.
And so 0.0062, right? Or 0.62%. So we're going to say that we're going to write up here, we're going to say the probability of x less than 220, or 200, sorry, 200 is equal to the probability of z less than negative 2.50, which is equal to normal CDF from negative infinity, which we typically write as just negative E99, to negative 2.50, and that's equal to 0.0062, which is equal to 0.62%.
Mm-hmm.
Okay, makes sense?
Yes.
All right, cool. Now let's go back to homework. Let's move on to number 4. Okay. See what you can do with number 4. The average salary for a Queens College full professor is $85,900. If the average salaries are normally distributed with a standard deviation of $11,000, find these probabilities. A, the professor makes more than $90,000. And B, the professor makes more than $75,000. These are separate problems, so you're gonna, but we don't have any betweens in this problem. See if you can set up A.
Mm-hmm.
And so here we're looking at more than 90. So probability of
Makes more than.
more than 90,000. 90, yeah, more than $90,000.
So 90,000.
90,000 is your X for that one, right?
Mm-hmm. Minus 85,900
Good. Yeah, that's good.
divided by 11,000.
Perfect. So then you have, let's see. Let me see if I can get it. So this is 90,000
Mm-hmm.
minus 85,900 divided by 11,000. And that gives us, I have 0.37.
Okay.
Is that what you got?
Yep.
All right. So now what do we do with that number?
We normal CDF it.
Right. We normal CDF it. Second distribution. Normal CDF number 2.
Mm-hmm.
What's our lower?
Infinity.
Not this time.
Oh,
Not this time.
0.37 or
Because, yeah,
37.
because remember, we're going up from there, right? We're not going lower than that. We're going higher than this number. So in this case, it's 0.37 or just 0.37. And this time we're going to infinity. So that's E99. So second distribution, E99. So that's, I mean, normal CDF, excuse me. But I'm doing wait, what did I do? Hold on. I did something wrong. Second distribution. There we go. That looks better. Normal distribution. I'm doing oh, that's not what I wanted. That's what I did. I entered the PDF instead of the, okay. Let me clear this out. Hold on. I made myself a made myself a mess here. Second distribution. There we go. Normal CDF number 2. And our lower is 0.37. And our upper is E99. So second, E99, 0 and 1. And I have 0.35